Okay, something that I want to go over first before I get into the homework packet number 3 and the Khan Academy skill involving sine and cosine functions. Let's go over what the basic sine and cosine functions look like. I've modified this graph right here, as you can see, to display um, these values from, well, starting at 0 here in the center of the graph, and then extending this first point of concern being pi, and then the second one being 2 pi. We're going to look at the x-axis in terms of pi in radian measure. All right, and so basically what we're doing is, like I did the first lesson, we are looking at, let's say, the sine function first, and we're looking at what the values are of the sine function as we move around the unit circle. So let's make a unit circle up here, and let's start at 0. Now the sine of 0 at 0.00 is 0, so everything's going to start right here for sine. In terms of going to the next place, which would be pi divided by 2, which is 90 degrees. In terms, okay, so we can say that angle measurement, pi over 2, that's how we would say it in radians, but we would say 90 degrees if we were saying degrees. So now if you type that in your calculator, you find out that the sine of 90 degrees, or the sine of pi over 2, is 1. So that's why our beginning of our sine function is going to start up, going up towards a value of 1. Okay, now as we head down into our next value to check, which is pi, if we type that in the calculator, we find out that sine goes back to 0 again. So that's what would explain this motion of our sine function. If we type in, and by the way, pi is right here on the unit circle. If we type in 3 pi over 2, which would be 270 degrees, right? This would be 180. This would be 270 right here. This would be 90. And this 0. That's where we start. It's also, aka, 360. So, if we type in sine of 270, or sine of 3 pi over 2, we get -1. So that's why we're going to extend our line down here. And then if we type in a value of 2 pi, we get back to 0 again. So this is the explanation of why the period of the regular old sine function is 2 pi. Because this is what it takes to get from the beginning to the completion of one cycle of the sine function. Now, if we went backwards, we'd find all this would happen all over again. We'd go down to -1, back up through pi, up to +1. All right, so we can see that this is the repeating pattern that we're dealing with. And that's how we know we're dealing with the sine function. It starts at a value of 0, and the first value it heads to is +1. Okay, now the sine function is what you see here in black. The cosine function, let's see what color we got here. Let's do this in red. So the cosine function, if you type that in for 0, you find out that the cosine of 0 actually starts at 1. It's when we go down to the pi over 2, or the 90 degree, that's when you find out that cosine is 0. So that is what explains this behavior for the cosine function. You go into pi, you find out that if you type in cosine of pi into the calculator, if you're in radian mode, or if you want to go to degree mode, or if your calculator is already in degree mode, you type in cosine of 180. You find that that's going to be -1. then we go up to the 3 pi over 2 mark, where we find out our function goes back to 0. And then if we find the cosine of 360 or the cosine of 2 pi, we find out that, there we go, bingo, the period is still in the same stretch of distance, but our cosine function looks a little different. All right, so if we got the regular old y equals cosine x, that's when you know that your function is going to be starting on the hump, as I like to say, up here, at 1, and it'll be continuing just like the sine function does. So it's basically the same as the sine function. It's just, it looks like it's being moved back a space. All right, see how this black line kind of starts up here 1? Well, it looks like the cosine just been moved back. It works the same way going backwards that the other one does, moving in the same motion. All right, so the period's still the same. It works like that. These are just two different functions. They look exactly the same. And I promise if you try all those in your calculator, it will work. So, and we're going to check out how to get these, how I do these problems systematically. All right, so you're looking at this new Khan Academy problem. And the first thing let's look at is, all right, we got a sine function, okay? So we know that it's going to look like what we have right here, like I was just saying. We're going to start at the center and move upwards. All right, let's notice a few things. The amplitude right here is 3. The center line is going to be around 4. So that's how we know that we can take our center line, and I'm trying to make a dotted line here. What we can do with that is we notice that the 4, which is the ending number, tells us where our center line is. Now, right now, by default, Khan Academy gives us the tool with our center line on the x-axis. So we know we're going to move that up 4 spaces because of this number back here. Okay, we also know that our amplitude is 3. So we know that this distance, it's set to 2 right now, but we know that we're going to move that to 3 in here in just a minute. Now, this number right here in front of the x is what helps us determine the period. And we know that the period function, or the formula we're going to use to find the period based off this number, we're going to call that number in front of the x. We're going to call that number b. Okay, so what we have here is that 2 pi over 1/3 should give us what our period is. Now, if I type that in a calculator, I mean, you can go ahead and try it. If you go 2 divided by, and you put your parentheses in there, and go 1/3 inside the parentheses, you're going to find that the calculator will tell you that it is 6. Okay, so somehow 2 divided by 1/3 is 6. Oops. Jumping on there. Okay, so here's how you can kind of conceptualize that. What you can say instead is 2 times the flip of this. So let's flip this over. And what we're going to get if we did that is 3 over 1. See what I did there? Let's say 2 divided by 1/3 is actually 2 times 3 over 1. Well, we can tell that 2 times 3 is 6. So hopefully that can help you conceptualize. Maybe once you start to get the hang of it, you can just grab this bottom number here and multiply it by whatever's on top. Now, sometimes you're not going to have a fraction at the bottom. Sometimes this number here in the front will be like 5. So you just say 2 pi over 5. You're good. So in this case, we have 2 pi over 1/3, so our answer is going to be 6 pi. So this is our total period. Total period is 6 pi. Okay, so that means that this whole function is going to need to wrap back on itself at not 2 pi, not 4 pi, not 5 pi, but 6 pi. So we need to get our function to wrap itself at 6 pi. So that means it needs to come from here up to the top, back to the middle, down to the bottom, and then back up to the middle. And this point here, it's currently hitting 4. We need to stretch it so that it gets to 6. So we'll boink it out, and there we go. Now, we can't quite see it because it's off the screen. And sometimes it's going to be way off the screen in these examples. So what we should do instead is look at, well, what do these two dots have to do with anything? Well, it's going from the beginning to the top point, which is 1/4 of the total period. Because here we are at the beginning. We go up to the top. That's 1/4. We go to the middle. That's 1/2. We go to the bottom. That's 3/4. And then we're back up to the middle. And that's the full period. Well, we want that to be 6. And we got that right now. But the way we figure out that is that we're going to divide this 6 by 4. So once we've figured out what our total period is, we divide by 4 to find out what 1/4 of our period is. And that's how far apart you need to space these two dots. Because when we do that, conceptually you should be able to tell that wherever that period is landing, and it's probably going to be off the graph, we want that period to be ending at what we've found to be our period through the formula. Okay, so we've got period taken care of. Like I said before, all we need to do now at this point is get our center line lined up, and we put a dotted line up here where our center line is going to be. So let's go ahead and move that up to the beginning. Okay, so and the other thing we discussed was the amplitude, and that's going to just be 3 spaces above the center line. All right, so we're going to go 1, 2, 3. All right, so we've got our graph starting at the in the normal orientation that our sine function is supposed to be, because this is a regular positive sine function. It just happens to be at a height of 4 with a period of 6 and an amplitude of 3. So we've got all those things. We know that we're at a period of 6 because of where our two dots are. They're spaced 1.5 pi apart. We know that the center line's 4. We've raised that starting point up to 4. And we know that our amplitude extends 3 points above that. So that's why we know that we're correct. And we're going to move on to the next question. Okay. So let's try another one. This one is going to be cosine. And let's go ahead and get started with making sure that we know that since we're dealing with cosine, we're going to move it so our graph starts at the top. Okay, and then it'll start moving down after that. Okay, so we know, hey, check it out. There's our center line right here. It's going to start at 6, so let's move that up to 6. All right, so that center line is always going to be where it's going to, back at the basic function, that center line is always 0. So imagine where that line started and just move it up 6 spaces. So yeah, I could draw that little dotted line for you if that helps. Basically, just make sure that, basically looks something like that. Okay, so next order of business is let's figure out the period. All right, so there's our little number in front of x. It happens to be pi over 12 this time. So period equals 2 pi. It's always like that. It's always 2 pi on the top. And the question is, what's going to be on the bottom? Well, this time it's going to be pi over 12. Whenever pi is in this situation, like in right here, they're going to cancel out. So we can go ahead and cancel out the pi's. Then, like I was mentioning before, we got 2 divided by basically pi over 12. Let's say 1 over 12. So we cancel out the pi's. That is going to be the same as saying 2 times 12 over 1. All right, well, that's 24. So basically our period is going to be 24. And if we look, our pi's gone, and it makes sense because when we have those types of problems, Khan Academy will take the pi out of the grid down there. So now all that, so we've got all that taken care of. We notice that we don't have any changes to amplitude this time, so our amplitude is actually going to be just 1, like that. So it's gonna, there's our center line at 6, and amplitude will just go over 1 like that. And again, we're dealing with a positive function, so we know that we're not going to be starting negative. We know that we're going to be starting at the top of the hill and moving down. So that's a positive cosine. So everything except for where we need to drag this sucker has been determined. We've got the center line dealt with. We've got the amplitude dealt with. We know that we got a period of 24, so we can divide that 24 by 4, and we'll wind up with 6. So our quarter period is 6. So we're going to drag our second dot 6 points away. So always look at the period, find out what that is, divide by 4. In this case, we get 6. Look at the center line, look at the amplitude, adjust accordingly, and you're good to go. All right, we'll do one. We'll go ahead and do one more, line one more up for you. I was hoping we could get a negative function, but you know, we'll just try one more. Center line's -1, so let's go ahead and move that. Well, let's position it like a cosine function. There we go. So that's our here's our typical cosine function. But we're gonna need to move our center line down 1. So we'll move this second dot down 1. So now our center line's at -1. Period is going to equal 2 pi over 1/2 in this case. So we'll have 2 divided by 1/2, which is 2 times 2 over 1, which is 4. Okay, so our period is actually going to be 4 pi today. Well, that makes our little quarter trick easy. Let's divide everybody by 4. And we find out that our dots need to be spaced 1 pi apart. Okay, so let's take care of that. There we go. All right, 1 pi apart. Our amplitude is 2 spaces above the center line, and we're good to go. All right, so here we go with a negative version. So this one's -7. We're dealing with a negative sine function, so we know that instead of the normal orientation where the sine starts in the middle and goes up, we are going to go below. So we're going to make this sine function upside down. Now, notice our center line is at 0.1. I mean, is at y value of 1. And we need an amplitude of -7. So basically what we're doing is we're saying that this center line is going to be a 1, but our amplitude is going to go down 7, which puts us at -6, right? It's always counted from wherever the center line is. So since that is +1, we'll go 1, 2, 3, 4, 5, 6, 7, which winds us up at -6. All right. So let me clear the info off from the last one. All right, so our period in this case is going to be P equals 2 pi over 1/4. So 2 divided by 1/4, which is 2 times 4 over 1, which is 8. So our period is going to be 8 pi. If you're confused on why sometimes the period has a pi in it, sometimes it doesn't, it's if there's a pi in here. Because if there's a pi in here, it's going to wind up in this fraction and it'll cancel out. So if there is no pi in here, there's going to be a pi in the period. If there is a pi in the what we call it the phase shift, then there's not going to be a pi in the period. Anyway, we got 8 pi this time. So let's think about how we're going to divide that. So if we divide our period by a quarter, we'll wind up with 2 pi. So you can check it out here. Wait a minute. Yep, we got our sine function. It's negative. Its center line's 1. Its amplitude 7. So we're going downwards. We're going to hit the low point first. That's going to be found at 2 pi because that is a quarter of our total period. So there we go. And hopefully we've covered all the scenarios that you would be seeing. Let's just check it out. I think you're pretty much always going to see a whole number as your amplitude. But of course, like if it gave you like a half as your amplitude, well, then you just shrink your line. You can't do that in these problems because we don't have any quarter or hash marks for anything lower than 1. But that is what you do if that were to come up. It's not going to come up, so don't worry about it. It should be good to go. Thanks for watching.